Good morning, children. We are going to start a new chapter, that is magnetic effects of electric current in physics. Okay, magnetic effects of electric current. You have studied about electricity, in your 7th standard, maybe from 5th standard you have started studying, but in 7th standard you have studied in detail about some of the components also. Okay, now we are going to study about magnetic effects of electric current. We have electricity chapter also in 10th standard, but after completing this chapter we will be studying electricity. Okay, so now magnetic effects of electric current. What do you mean by that? Do they have magnetic effects? Okay, we are going to study electricity. Before that, do they have magnetic effects? We are going to study in detail. The first thing which I have written in this chapter is electricity and magnetism are linked to each other. Okay, electricity and magnetism are linked to each other. So they both are having a link. Who said this? Now I am telling. But it was first told by Hans Christian Ørsted. Okay, Hans Christian Ørsted. Who is he? He is a Danish physicist. Okay, he said that electricity and magnetism are linked to each other. Can he just tell like that electricity and magnetism are linked to each other? No, people will not agree. He should demonstrate with the help of an experiment, right? It was first found accidentally. It was not intentionally, accidentally. When he was doing an experiment with the electric current, he kept a magnetic compass near that and he found that the needle got deflected. And with the help of an activity, he explained that electricity and magnetism are linked to each other. We are going to study that experiment in detail. But now, in one line, electricity and magnetism are linked to each other. Who said this? Hans Christian Ørsted. Okay, in the year 1777 to 1851. He found it in the year 30 years before his death. Okay, found the year. And he is a Danish physicist, I said. I read about him. You should also read about Ørsted. Okay, the two interesting and important facts which I like most is, see, I have written piperine and aluminium. Piperine. What is piperine? Piperine is a chemical compound. Do you know where it is seen? It is found in pepper. When you are down with fever, your mother used to prepare, that kashaya with pepper. It is having some pungent smell and the flavor and the taste also. It's an alkaline taste, so it will be very hard, right? So he isolated and extracted the chemical compound called piperine from pepper. It was very interesting according to me. Okay, that's the first fact about him. The second one is he found aluminium. Where is aluminium seen? Find it out, okay? He found aluminium. So these two things I like more. So I have written. You should also try to find something which is interesting about Hans Christian Ørsted. Okay? Now we will come to the next part. Before studying magnetism, we should know little bit more about magnet. You have studied about magnet from your lower classes, from 2nd, 3rd and all you have studied, but we'll see something more. We'll just brush it up, okay? So natural magnets as well as artificial magnets. You know, natural magnets are naturally found and artificial magnets are man-made. Okay, natural magnets, some example what they have given is lodestone. Before that, there's a story like who found magnet first. Do you know about this shepherd boy, Magnus? Find it out, okay? He was the first person who found magnet, it seems. Okay, you find it out. So, natural magnets, example is lodestone. And certain rocks behave like magnets. Okay, certain rocks, they behave like magnets. They contain, what is there inside? Magnetite. See here, magnetite. The chemical formula of lodestone is Fe3O4. Somewhere you have studied, no? Fe3O4. Okay, they are magnetic compounds. Okay, so these 2 points about natural magnets. And there are some other natural magnets, but they are weak. They are not like lodestone. Okay, they are weak in nature. Some 3 examples I'll give: pyrrolite, ferrite, and columbite. Okay, pyrrolite, ferrite, and columbite. It is not there in your textbook. It will be useful for you when you go for some competitive exams. Okay. And this is about natural magnets. Artificial magnets, man-made magnets, I said. No? Artificial magnets are of 2 types. They are permanent magnets and temporary magnets. Permanent magnet means what? Magnets whose magnetic strength never fades. Always it will be permanently, it is a magnet. But temporary magnets means they aren't always magnetic but can be turned on at will. If you want, you can make it as a magnet. If you don't want, you can leave it like that. Okay, they are called as temporary magnets. And an example for permanent magnet is alnico. See, then it is different, no? Alnico, it's an alloy. Alnico is an alloy. It's a combination of aluminium, nickel, cobalt. Okay, aluminium, nickel, and cobalt. It's an alloy, and that is called as alnico. It's an example for permanent magnets. Temporary magnets, as I said, they are not magnetic. They are not always magnetic. If you want, you can make it as a magnet. It can function in the presence of electric current. Okay, keep this in mind. They can function as a magnet in the presence of electric current or magnetic force. Okay, this is a very important point. I will be asking it later. Now, there are some more examples for permanent magnets. Alnico is very important. With that, carbon steel, copper steel, tungsten steel is also examples. Where is it used? It is used in the refrigerator door. When you open your refrigerator and when you leave it, it will go and it will close automatically. You know, it is because of which magnet? Permanent magnet. And not only the door, that gasket which they have kept, no, that strip also is made up of, that outer layer is made up of magnet. Okay, gaskets. Then galvanometer, you will be studying about all these things. Galvanometer, voltmeter, ammeter, speedometer, loudspeakers, microphones, all these things. What is the use of this? They will be using permanent magnets. And for permanent temporary magnet, iron nails. Iron nail can be used as a temporary magnet. You have seen that experiments, no? Small experiment, iron nail. And paper clips. What do you mean by electromagnets? I have put a question mark. Find it out, the definition for electromagnet. Okay. Just now I said that, but you should find it out. What is the definition for electromagnets? It's also used in electric motor, telephone, cranes. You have seen, no? Cranes lifting the things from the. They used to put everything in one place, and in big factories and all, if you see, cranes will be used to lift. Okay, cranes, then speakers, then microphones, cars, computers. You'll see temporary magnets. Okay, so these are the uses of artificial magnets, that is permanent magnets as well as temporary magnets. We'll also see about the characteristic. We have seen a magnet, right? Magnet will be like this. What are the things you have studied in your lower classes? One north pole and south pole will be there. We can also tell the north pole as north-seeking pole and the south pole as south-seeking pole. Okay, we used to tell north pole, south pole, but it can also be told as north-seeking pole and south-seeking pole. We know that like poles always, what will they do? Like poles, they will repel. That is very important. Like poles always repel each other, and unlike poles always attract each other. It means if you bring two north poles of a magnet, this I am taking one magnet here and one more magnet here. If north poles are kept and if I bring them near, will they attract? No, it will repel. If I bring a south pole near a north pole, what happens? Automatically it will get attracted. So unlike poles, they attract each other. And shapes, we have seen many shapes. They may be in bar shaped, rod shaped, ring shaped, disc shaped, horseshoe shaped. Okay. And bar will be like this, right? Bar magnet, rod magnet you have seen. Have you seen this ring and disc? for ring and disc, here for bar and rod, if you see, one north pole and one south pole will be there. But in ring and disc, if you see, there will not be north pole, south pole. It will be in ring shape, no? So one face will be considered as north pole and the other face will be considered as south pole. Horseshoe magnet. Why it is called as horseshoe magnet? What is the shape of this? It will be in U shape, right? Why is it called horseshoe? It is not like human shoe. It is horseshoe. Why? Have you seen that in horse? Find it out, okay? Why it is called as horseshoe? Okay. So here, if you see, it will be in U shape like this, and north pole will be here and south pole will be here. So both the poles are near, see, not like this. So the magnetic poles are closer compared to this. Magnetic poles are closer and they are very strong. Okay, so horseshoe magnets are used. And magnetic effect of electric current, no? So how will your magnetic strength, the unit of magnetic strength is, it is represented by capital H. Okay, capital H. And the unit of magnetic field is OE. I have written. Why I have written OE? Have seen anywhere OE? See here. To honor him. It is very important, no, to honor this person. So they have given the unit of magnetic strength as OE. You have studied about CGS system and MKS system, I think, in your lower classes. In CGS system, it is given as OE. The unit is, that is Oersted. And in MKS system, it is ampere per meter. Okay, ampere per meter. These units. And some more points about magnets, if I like to tell. If you cut a magnet into two, see a rod, bar magnet or a rod magnet if you are taking, and if you cut it into two, here north will be there, here south will be there. If you cut this into two, what will happen? You will get two magnets. This side will be north and this side will be south. And again this side will be, find it out, okay, how it will be. But you will get two magnets. It always exists in pairs. When suspended, when you are allowing a magnet, when you are just tying it with a thread and you are allowing it to suspend like that, what happens? It always comes to north-south. It will focus north-south direction. It will not show east-west. It will show north-south direction. When it is kept away from other magnets, the north pole of the needle always point towards the geographical north of the earth. Do you know that earth is also a magnet? Right? Earth is also a magnet, but there is no bar or rod or horseshoe inside our earth, no? What is there inside? It is in molten form according to us. Crust, mantle and core. The core part, okay? What is there in the core part? Find it out, okay? But earth is also a magnet, but what is there inside? So here, I have put a question mark here. Navigators use magnet. What do they use, navigators? They use something, no, to find the direction. What is that? I told this word, find it out. And I have also asked you one question, that is MRI. What do you mean by MRI? Find out the expansion of MRI. Okay. You have heard about scanning, MRI scan, right? In our body, in human body, there are two important organs where we take the scan, MRI scan. If we are suffering from cold, do we take MRI scan for our nose? If we are suffering with stomach ache, do we go for MRI scan? No. We used to take only for two organs. Find it out. Okay. So this is an introduction about magnet. We are going to study about magnetic field lines in the next part. Quickly we will see what we have studied. It's very important. The very important point in this part, in this subtopic is electricity and magnetism are linked to each other, and the person who found this. And also I said about this person that piperine and aluminium was found by him. Natural magnets, example is very important. Lodestone. This time you are going to study many MCQs. So each and every small information which I am giving now, you should keep it in mind so that it will be useful. So lodestone, the chemical formula for this magnetic compound is Fe3O4. It is also called as magnetite. If they can ask like magnetite's other name is lodestone or lodestone's formula, like that they can ask. And they can also ask other natural but weak magnets. What are those? Ferrolite, ferrite and columbite. Artificial magnets, I said, there are two types of artificial magnets, permanent magnets as well as temporary magnets. Definition for permanent magnets. Magnets whose magnetic strength never fades is called as what? Permanent magnet. One example I have given, alnico is an alloy. We have also studied about temporary magnets and what is the definition for temporary magnets, other examples for permanent magnets, and then uses. Characteristics, some 4 or 5 characteristics we have studied. Like poles they repel, unlike poles they attract each other. Shapes, and also they exist in pairs when suspended. Always they come to north-south direction. When they are kept away from the other magnets, what they will do? They will always point towards the geographical north of the earth. And find out the expansion of MRI. Okay, MRI. Okay, bye.